lesson is about writing numbers in scientific notation. So let's take a look at two examples that I have written. We're going to change 687, which is in standard form, to scientific notation, which would be 6 and 87/100 times 10 squared. Notice what we had to do. Here is my decimal point, and I have to have a number right here that is greater than 1 but less than 10. So that means that I am moving my decimal point over 2 spaces. Therefore, I wrote 6.87. Now, those 2 spaces, every time we're moving it by 1 spot, this is by tens, we are going to write that number of spaces as our exponent for our power of 10. Looking at the next one, well, this is a decimal, very small decimal. It's 7,212, and that is 10 thousandths. It's tiny. But now I'm going to apply the exact same rule that my first number must be greater than 1 but less than 10. So for this problem, I am going to go ahead and I'm going to move the decimal point to the right. And when I move the decimal point to the right, if you notice, our exponent is a negative. So again, when I move that decimal point, I end up with 7 and 212 thousandths times 10 to the negative 1. Whenever we have a number that is greater than 1, notice our exponent is going to be a positive number. Whenever we have a number that is less than 1, our exponent is going to be a negative number. And our base here will always be a 10 because our number system is based on tens. So let's look at number 1, 2,900. I know that here is my decimal point, and I must move it all the way over where that comma is in order to have my first number being between 1 and 10. So I end up with a 2, and there's my new decimal point, and I can write the 900, or I just can write it as 2 and 9/10, and now I'm going to count how many places I've moved. 1, 2, 3. So this is times 10 to the third power. Again, either one of these is correct because there's just always understood zeros after a number in your decimal system. So number 2 is a very small number. I see here's my decimal point, and I am going to move it so I have a number between 1 and 10. So this number is going to change to 8 and 71/100 times 10. And now let's count the spaces. 1, 2, 3. So it's to the negative 3. Looking at just 185, here's my decimal point. So I know I must move my decimal point over to where the first number is between 1 and but less than 10. So I end up with 1 and 85/100, and I've got to count how many spaces I've moved it. 1, 2 times 10 to the second power. We're getting bigger. We have 3 million, and here is my decimal point. So my decimal point has to move all the way over to where I have a number between 1 and 10. So this is 3 times 10, and this was a really big number. So I'm going to count 1, 2, 3, 4, 5, 6 times 10 to the 6th power. Number 5, and a definite smaller than 1 number. So I know my exponent for my power of 10 is going to be negative, and I've got to move it all the way over right there. So I end up with 6 and 5/10 times 10. Now let's count how many spaces. 1, 2, 3, 4. You do have to count that 6 because we've got to get between the 6 and the 5. So it's to the negative 4. And last but not least, a nice big number, 793 million. I'm hoping that's how many viewers I have. And here is my decimal point. I am going all the way over to a number that's between 1 and 10. So my new decimal point is my number is going to read 7 and 93 hundredths. And again, you could write all those zeros, but this is really the best format. So if you have extra zeros on the end of that number, you can totally just leave them off. So now we know it's times 10, and we're going to count how many spaces we moved over. 1, 2, 3, 4, 5, 6, 7, 8. So it's 10 to the 8th power because this is a large number. Just to recap, when you're writing in scientific notation, if you have a number greater than 1, your exponent is going to be positive. If you have a number less than 1, your exponent is going to be a negative. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marsha. See you again soon.